and it's gone. It's off. Then it waits till the second hand is up at 0, 0 again, goes for 20 seconds. In the cancerous kind of diseases, it stays on all the time, maybe for 5 minutes, and then it takes 1 minute off. So it's very much accelerated there. And every time there was this disturbance, lasting just about a second, there was a disturbance in the DNA becoming free. And that disturbance didn't immediately, the DNA timing change didn't immediately go back. It would stay there, and it would take minutes before the timing came back to the normal timing. It was not at all as quick as the magnetic disturbance. Then I wanted to know, was the disturbance south or north? Is this deflection here? It doesn't tell you. The deflection is just a total deflection, either north or south. It's total. And for my DNA observations, I wanted to know whether the field had become more south or more north. So then I got I thought, if it is the magnetic field, there'd be one other way to test this. Just hold a magnet on you. So I got big magnets, little magnets. You have to hold a tiny magnet that's around 10 Gauss, about this far away from the body, in order to see data. We looked all over the body and different points that are discussed by different healers. I couldn't find anything. We didn't do a very intensive job, but found that if you held this magnet right over the spine, it changed the timing of DNA. And if you held the magnet so that the south pole of the magnet was aimed at your spine, the center spine, actually it was just to either side of the spine, about 1/4 to 1/2 inch of either side, maybe where the sympathetic ganglia are going. I'm not sure if that's it, but if you aim the south pole field right at a line parallel to the spine on either side, you get the deflection the same as the magnetic field does, to the right later. So if you have magnetic field exposure to your body at the right place, you have a change in the DNA expression that is to the right later, expressed later. Now, if there was no disturbance, the DNA would stay on. In other words, you'd be seeing it for a 20-second quantum of time. But if it's late in starting, like 7 seconds later, it doesn't go off 20 seconds after that. The whole quantum is somehow affected, and it usually stays on till around the 40-second mark. It should be 27, right? If it's late by 7 seconds, it should have gone to 27, and it didn't. It was always on too long if it came on too late. If you turned the magnet around so that the north pole was aiming at you over the spine, the DNA went the other direction. It became earlier. by this definition. It would be earlier. And just as strong, it would seem that it has its effect within the first 10 seconds or so. It's immediate, almost immediate. You might think that the field from a little magnet like that doesn't travel very far. And I'm searching for the DNA in the kidneys way down here, but the effect is very quick. Somehow, that magnetic field can reach much farther than we thought it could. So I thought we might have something in the blood which would be closest to the magnet that is responding and picking up that response and carrying it everywhere, because it didn't matter where I tested the DNA. Bone marrow or kidneys or adrenals or wherever, it was still affected by this magnetic field change. And I tried experiments on the blood, but I never got anywhere with them. I now know that there is a change in polarity in the blood, but I didn't know it then, and I didn't know how to research it. And if you can give me an idea on how to research better, I would like to know it. Because somehow a little bit of a field change close to us can affect me in my toes, which goes against ideas of how far the field reaches. So now I could see that a magnet, a human-made magnet, can affect the DNA expression. But whether it affects cell multiplication, that kind of DNA expression, I still don't know. That's for you to research or give some good ideas. And I think that some of these observations are independent of each other, so that they add to the validity of the results, of the conclusions drawn. And I know that there have been efforts made to relate the Earth's magnetic field to our DNA, and I think we don't have to be quite so speculative anymore about it. We should go ahead and measure it. We should start measuring without feeling that we're so far out about it, because you can measure this all yourself. You can see that the DNA timing is affected, and of course it would be nice if I could find some result of the DNA change that we're familiar with, some gene being affected or some chemical production being affected, and I haven't done that yet. That needs to be done, but it's looking very likely that the magnetic field might be in control of, not just affecting a little bit, it might be in control of DNA expression somehow. And that means there has to be some little thing that feels it, a transducer. Somewhere there has to be a transducer. And I think in the new book, I talk about the concept of iron in its different oxidation states, Fe2O3 or Fe3O4, being the pair. And that could be the pickup mechanism that is transducing or being affected by the field. And I think that the Rifers are the first people I would like to come to with such speculations, because they think about these matters too. It's interesting, maybe a little devastating, to think that the sun's flares are giving us only South Pole influences. I never saw a deflection from a flare that turned the DNA in the other direction, which is the North Pole field. I never did see that. I only saw this South Pole influence. And we need to try to know what that means. In the new book, I have a short chapter on some other, cosmic-related kind of phenomena, and I talk about polarization, which is not the same as polarity. So I'm switching the subject right now to make sure you know that I'm switching the subject, because I finished telling you about the phenomenon, that the phenomenon that I think there is enough evidence to state that the magnetic field does influence, if not control, DNA expression, at least in making proteins. The RNA is not affected. It always seems to come right after the DNA. If the DNA is late, RNA is late. DNA is early, RNA is early. So I take that to mean that after the DNA has copied a certain section of gene material, that 7 seconds later, which is how much later the RNA is, you see a protein developed. You copy the gene, then you get into transfer RNA and so on, which is reproducing that enzyme or piece of protein. And that isn't affected by the field except indirectly. So the end of that phenomenon, I now wanted to shift and say that I talk in the new book about a phenomenon that I call polarization, and it's my own term because I can't think of a better one. If you can think of a better one, let me know too, because I know that polarization is used in 2 dozen different ways. If you put water into a magnetic field, I've never picked up magnetization of it. I've never, even though I put it in a North Pole field, I can't take a compass like this and see that it is now North Pole or South Pole or anything. But maybe I never had a good enough compass, right? I need a Hubble attitude here to make, and they already do make very good compasses. It's just that I couldn't afford that, and so I've never found a pole. But if you put the water that you had in the North Pole field on the oscillator, it will indicate its presence if you hold a little magnet on top, right nearby, on top of the other plate of the instrument. So you can identify that something happened to that water. And it happens only, you can identify it as the very field that you put it in. It's never different. And water is known to belong to that category of substances called dielectrics, so that, and tissue also, so that it doesn't act like metal. Water does not act like metal. It acts opposite to metal. If you hold a magnet to a piece of metal, you get the opposite pole coming out of that metal towards you, and if you're holding the North Pole on the metal, a South Pole is attracted out of the metal and comes closest to you. But in water, it doesn't happen like that. It's the same. In dielectrics, it's the same pole that comes to the pole that you're putting close to it. And you can never actually measure a pole, so I call it polarization. I can't measure polarization with a compass. I can only measure polarization with the oscillator. I don't know why. And I can't measure that polarization with this device either, nor with, I can't measure it with any device I have. I also have this thing called a Gauss meter or a magnetometer, where you could measure a field quite accurately, right down to a very small fraction of a Gauss. And this measures milligauss changes. I've never seen it, but that doesn't mean that it isn't there, say, in micro-Gausses. It might be, and I would be very excited to get a device for Christmas that could measure in micro-Gausses. Then you wouldn't see me for a few years. I'd be in a basement somewhere doing these experiments. But the water did undergo some change, and in order to identify that, I call it polarization, north polarization or south polarization, even though I can't find a pole in it. The influence of the field is easy to see. And you can measure those polarizations in any tissue. They're all over us. And during the daytime, our bodies are always north polarized. In other words, if you put a sample of a tissue on the oscillator and you test to see what kind of polarization it is, it's north. In other words, it will indicate its similarity to a sample of water that you had put in a North Pole field. But the nervous system, the brain and the nerves, have south polarization. So if you put a sample of your brain or any nerve on the oscillator plate, it will indicate that it's present and equal to, similar to, a sample of water that you had put in a South Pole field. I don't know what it means. It has been intuited and maybe tested and measured. I think that phenomenon has been seen by many others before me, and it just hasn't had explanation in terms of the kind that I'm used to looking for or looking with. But the phenomenon is there. Yes?
There's a very simple experiment that anybody can do to observe the effects of magnetized water on living systems.
Yes.
I.e. water that's been under the influence of a direct magnetic field. You can take water and put it on a, like I say, a negative facing a magnet and have it sit there for a while. That magnetizes the water.
Yes.
Have another control sample that's not magnetized. You take two live, I use flowers, cut them at the same time. Put one in the magnetized water, and put the other one in the control. And then observe to see what the effects is. You'll find that
the effects is of what?
You'll see what the effects are between the difference between the control and the magnetized water. The one that's in magnetized water.
Yes.
The one in the magnetized water will last at least 2 to 3 times longer than the one that's in the control.
Okay, that should be easy enough to do. I'm going to do that. Is there a difference between South Pole and North Pole magnetization of the water?
Yes, there is.
Okay, you leave that for us to figure out, to observe.
Yeah.
Okay, thanks. Appreciate that.
Dr. Clark, are you familiar with paramagnetism?
Yes.
Where light poles attract each other, Philip Callahan's work?
I've read that. I think I use it in a little different sense.
Okay.
I'm using paramagnetic in the sense that there's a set of elements that includes thulium and holmium, a whole set of paramagnetic elements, which we now have polluting our foods and so on. And if I have experimented a lot with those, especially with thulium, because it pollutes reverse osmosis water, and we immediately get that element, thulium or any of the other 15, and that delays DNA expression to 13 seconds, much more than these blips coming from the sun. And it's very hard to get rid of. It won't come out like an ordinary heavy metal. You have to use a special tactic. I discuss it a little bit in the book. Maybe your information is still different, and if you come tomorrow morning to the class where we're going to measure these things.
What time?
I think it's 9 o'clock.
Okay. Also, he had a tester that would test the very low levels of this paramagnetism in his book, and I don't remember exactly what it was made of, but it was fairly simple. Also, there's something called a spin tester that will determine the spin, whether it's left-handed spin or right-handed spin that the Germans developed.
I would like to know more about that, too.
Because that can be affected by magnets. Whatever you magnetize, the spin tester will tell you whether it's a clockwise spin or counterclockwise spin, which is also like north and south polarization.
Yes.
So, yeah, well, I'll talk to you.
All right. Thank you. Thanks for your contribution.
I just wonder, Dr. Clark, if you could clarify when you say daytime, whether you're talking about daytime clock time or whether you're talking about sunlight daytime.
This effect starts in the morning at the first ray of sunlight that it's within 1 second of the sunshine that your eye picks up on. If you close your eyes, you can make it a little later. But otherwise, it seems to be the sunshine. But in the evening, it does not seem to be the sunshine. It seems to be much more complicated. And within a half an hour or so of sundown is where you have the change in polarization of the body, so that the whole body now switches to south, and the whole brain and nervous system switches to north. There's a switch just like that in the morning, but in the evening, the switch takes a half an hour to an hour to become stable. In the evening, it isn't stable. First you have the switch, then you switch back again, and you switch again, you switch back again, and at a certain time, maybe a half an hour or an hour after, or half an hour after sundown, it's stable and remains permanent.
Have you tried this by any chance in extreme latitudes?
No, I haven't. And
Interesting.
yes, would be very, very interesting. I tested the saliva and the urine, and they reflect the body. If the body is north, the urine and saliva are north. If the body is south, namely nighttime, the urine and the saliva are south polarized. The lymph is south all day. You would think maybe it should be north, but it is south without any fluctuations. But the blood, and here again, I think this makes the blood maybe really the focus of all of this. It flips by the minute. 1 minute north, then a minute south. 1 minute north, then a minute south. And the element iron oxide, one of the pyrite family, Fe2O3 and Fe3O4, seems to be the pair that is making this change. I'm sure it couldn't be by itself, but it might somehow be iron. And the turning on of DNA and the stopping of it could be iron too, because the body makes DNA out of RNA using an iron enzyme. First the body makes RNA, then you make DNA out of that. And the iron enzyme, I talk about it in the book, has an unusual iron atom in it that has to go much, much further a distance in order to accomplish its purpose of making DNA, a deoxy form of the molecule. It's not doing very much, just an oxidation reduction kind of action, but the iron electron has to move a much longer distance than any other enzyme known. So it seemed to me that would be a candidate for being influenced by the magnetic field. Of course, that's exactly what you do in a cyclotron. You're just influencing the movement of an electron, and it had my special interest because I did that kind of research when I was 18 or 19 years old, and at that time, I didn't do it for this purpose. I was doing it because I thought that you might induce mutations this way. And indeed you did. I was just getting a master's degree for that. But it did get published in Nature of London, which publishes very short articles and of fundamental interest. So I hope that you find the key to this so that you can publish this in Nature. That would give me a very special pleasure, because that's where it belongs. People have been trying to find absolute evidence of the magnetic field of the Earth doing something to living systems, and doing something to your DNA is most fundamental. It would certainly deserve to be in Nature. How's my time going, Tim?
Half hour.
Left?
Yeah. You can take a break if you want.
Yes, I'd like to drink some water. This is heavy. This is high-density polyethylene number 2. It's the